Today, Lesson 17a, Solving Absolute Value Inequalities. So, essentially, this is the last lesson of Unit 1. And it relies on basically two things that we've already learned. And one of them is solving absolute value equations. Similar to that, but also similar to compound inequalities. So if you sort of put those two things together, that's what solving absolute value inequalities is all about. So today, solving absolute value inequalities, describing solutions to our answers, and the typical why am I learning this? All right. Absolute value of x is less than any number. Absolute value of x is greater than any number. This basically narrows it down to the two types of problems that we're going to talk about today. When we have an absolute value of something, of some variable or something with a variable in it less than any number, we're going to split that into two inequalities, much like we did with equations. One of them is x is less than whatever that number is, and the other one is x is greater than the opposite of that number. Now, the first question that usually comes up is this, because everything seems to make sense, because it's just like we did when we solved absolute value equations, except for that right there. Notice that I flipped the inequality symbol. Any idea why I did that?
Oh, because you had to switch it to a negative, so you had to flip the symbol.
Why, though? Yeah, I switched it to a negative. So what? Right? But why did I flip?
In order to switch it to a negative, you would have to divide x by a negative number.
Yeah, so you basically, in order to either had to multiply by a -1 or you had to divide by a -1, either one of those tell you that you have to flip the inequality symbol. All right, so one other thing is that a less than absolute value inequality is always an and compound inequality. And you need to make sure that you remember that. So we'll talk about one little tip that might help you remember that in just a second. But greater than absolute value inequalities, we split that into two inequalities. One is x is greater than the number, or x is less than the opposite of that number. So less than compound inequalities less than absolute value inequalities turn into and compound inequalities, and greater than absolute value inequalities turn into or compound inequalities. So as I mentioned earlier, it's putting two things together. What we did when we solved absolute value equations with compound inequalities. And so here's a little tip that over the years has helped people remember when it's supposed to be and or. Less than is similar to the word and. So if you sort of remember less than, if you put those two things together, that has helped some people remember that over the years. And greater than is similar to greater than. And once again, over the years, this has helped people remember that less than and greater than or. Okay? All right. Number one, remember, anytime that we are asked to solve any equation or inequality, we're trying to figure out what numbers can go in for the variable to make a true statement. But we just learned how we're supposed to split this up. So let's split this up into two inequalities. The first one, of course, is x is less than 5. Will this be and or? And. And then the second inequality should be x is greater than -5. So for this absolute value inequality, there wasn't much to do there. So we have basically two ways of writing the solution. And we kind of talked about this yesterday with compound inequalities. You can write your answer like this, or you can also write it like that. It doesn't matter which one. And then we all know how to graph that, obviously. Number two, we would split that into two inequalities. The first one is x is greater than 5. And this, of course, is an or statement. The second one is x is less than -5. Now, for or statements, That's really the only way to write your answer. Okay? And then, of course, the typical graph for an OR statement looks like this. So everything should be nice and easy so far. Nice and easy. But now let's take a look at number 3. Any ideas on this one? And we're sort of piecing together lots of different things that we've done in the... Any ideas here? John?
I think, I'm not exactly sure, but I think there might possibly be a solution because it's less than or equal to.
Okay. Give me a number that would make a true statement there.
It's no solution because since the x is in the absolute value bars, it has to be a positive number, and no positive number is less than -2.
Perfect. You said it perfectly. It doesn't matter what you put in for x. When you take the absolute value of it, you're going to get something that is bigger than any negative number. So therefore, the answer is no solution. Now, look, let's pretend like you went into automatic pilot and you did this. Right? The less than or equal to compound inequalities are and statements. And statements are intersections. There is no intersection there. And we talked about that yesterday. Since there's no intersection, and this is why, to me, the graphs will tell the story for you if you do go into automatic pilot. That graph, there is no intersection, therefore there is no solution. How about number 4? So let's go into automatic pilot. Everybody go into automatic pilot and split it up into 2 inequalities and graph your solution. Then let's talk about it. So most of you have split it up into 2 inequalities and you've done your graph. Can you quickly turn to your shoulder partner and talk about what you think the answer is for this and why you think it is what it is? All right, so now, what do we think?
I believe it is infinite solutions.
Okay, and it is infinite solutions. Think about this for a second. It does not matter what you plug in for x at this point. You're always going to get a number that's bigger than -2, right? Or for that matter, you're always going to get an answer that's bigger than any negative number. But if you didn't notice that, and you went into automatic pilot, as I've said before, and you start going through it, and greater is an OR statement, which is supposed to be a union. So you graph the first one, you graph the second one, and we saw that today from previous homework assignments. We have a union here. Yes, we have an overlap, but who cares? It's a union. And so when you put those 2 pieces together, the entire number line is covered, and that leads to either infinite solutions or all real numbers, whatever you want to call that, because once again, we're talking about the union there. All right, so we have to keep all these things in mind when we are solving absolute value inequalities. So let's quickly summarize all these things we've been talking about in Unit 1. And we've talked about a lot of things here. Summary of no solution and infinite solutions. When we're talking about equations, the answer to that, of course, is infinite solutions. We end up with the variables canceling, and we end up with a true statement there. Any number you plug in for x will make a true statement. In this one, no solution. The variables cancel, you end up with a false statement, or another way of looking at it is this. Nothing that you plug in for x will ever make a true statement. Absolute value equations. No matter what you plug in for x and add 7 and take the absolute value, you will never get -3, or for that matter, any negative number. Therefore, no solution. Inequalities. Similar to equations. True statement there. Therefore, infinite solutions. Anything you plug in for x will make a true statement. This one, we end up with a false statement, or anything you plug in for x will never make a true statement, therefore no solution. And then we have what we just talked about a few minutes ago with absolute value inequalities. And the graph in these is always the surefire way of checking to see whether it may be one of those two if you're not sure. All right, so let's start at number 5. The absolute value of x minus 5 is less than 3. We need to split it up into 2 inequalities. Go ahead and do that. Will this be and or? It's and. Is that a union or an intersection? Intersection. Good. All right, Morgan, I'm going to go ahead and set this thing up. All right? And then I want you to tell me what you got for your solution. So the solution is?
The solution is
2 and 8.
Oh,
This is not an equation,
no.
right? Not an equation.
The solution is 2 is less than x is greater than 8.
How'd the less than on this? Is it greater than 8? Did you say x is greater than 8? Is that what you said?
Yeah, x is less than
X is less than 8. There we go. So solving it this way, we just solve it like we would a normal inequality for each of them. So we get x is less than 8 and x is greater than 2. That's one way of writing your answer. But that also turns into this. But I want to show you another way of doing less than absolute value inequality. So in your notes where it says another way of setting up less than problems, that's where you need to write this down. Let me go ahead and graph this thing really quickly. We can set up less than absolute value inequalities like this instead. So we know we have this, but I'm going to set it up like this. So I want you to write that down. And then I want to talk about how those two things are really the same thing. Okay, so I think it's obvious where we got this part of it, right? Because that's this one right here. But if you think about this one backwards, that's this part right here. And that's exactly why you can set it up just like that. So if I go backwards for a second here, you set it up like this first, and then basically the opposite of, the opposite of this is what's going right there. Okay? So we can set up all less than absolute value inequalities as one inequality and then solve it, and you can see quickly how we can get 2 is less than x, which is less than 8. And to me, that's the faster way of doing less than compound, or less than absolute value inequality. All right. Everybody try. Number 6. And I don't care which way you do it. You pick the way which is better for you as far as the and compound inequality. A.
The solution is x is greater than 2/3 and less than 2.
Okay, so you split it up into 2. Can somebody give me the answer as one inequality?
2/3 is less than x, which is greater than 2.
Which is what?
Greater than 2.
So did you do it as separate ones and then try and put it together?
No, I meant less than 2.
Okay, there we go. Yeah. So if you split it up, it would look like this. 3x minus 4 is less than 2, and less than is and. 3x minus 4 is greater than negative 2. We solve both of those. That part of it, of course, should be easy. Just remember all the general rules with regards to inequalities. And if you piece it back together from there, that's also fine. Graph looks like this. Or my preferred way of solving less than ones is to put it as one, or write it as one compound inequality like that, and then solve from there. But either way, the solution is 2/3 is less than x, which is less than 2. Okay, so I think at this point we're going to jump to number 8. Everybody do number 8. Yes.
So for the less than, that's the only method you can use that for. You can't use it for.
Correct.
Okay.
Yeah, we just had a good question. The question was, can you do or compound inequalities as one inequality? And the answer to that is no. You have to split both of those up. in this one, we need to split it up into two inequalities. Greater than or equal to leads to an or statement. We solve both of those like we have hundreds of times. And we end up with x is greater than or equal to 6, or x is less than or equal to negative 10. That's what the solution is. Graph, of course, looks like this. Now, I'm going to quickly go through number 9 because I think it's fairly obvious what we are supposed to do. And if it's not, we're going to clear it up right now. All the other problems, the absolute value was by itself. In number 9, it is not by itself. How am I going to get it by itself? Inequalities work just like equations. We have to get the absolute value part by itself before we want to split it up. So what should I do first, quickly? Add 6 to both sides. Then what do I need to do? Just say it. Divide both sides by 2. If you had to divide by a negative number, of course, you would flip, but we don't have to in this one. And then from there, it's like all the other problems, okay? We split it up and solve. It's less than or equal to, so that leads to an and statement. And we should already be thinking about what an and statement is supposed to look like when we graph it. And of course, there is an overlap there. And so the graph looks like this, the intersection. All right, last problem for today. Number 10. Solve and graph, please. On this one. Subtract 5 from both sides. Let me do that. Okay? And? Divide by negative 3. What do I have to remember to do when I divide by negative 3 in this one? Yeah, and so what was an or statement is now going to be an and statement. Okay? Any questions so far? And at this point, you should be able to stop. What's the answer? No solution, exactly. Now, if you went into automatic pilot, you would see it because this is supposed to be an intersection, and there would not be an intersection if you solve that the way you would normally solve it. But hopefully you saw that it would be no solution. And remember, the graph of no solution is nothing over the number line. Okay? All right, you have tonight's homework. Get your name on it.